Hello everyone, welcome to F3 Learning. My name is Alam and today I am going to discuss about the 10 key points to design your fire pump, to select or size your fire pump effectively. So let's start now. The first one, you have to calculate the system demand, right? The very basic, you have to make sure what is the demand needed for your facilities, right? So let's say this is your facilities which contains some hydrant lines and then sprinkler system and standpipe system for this scenario, and all the demands are here. Let's say for the sprinkler we have 735 GPM at 91 psi, for standpipe system which is 1250 GPM at 160 psi, for hydrant 2000 GPM at 20 psi. So if you are taking these scenarios, one thing comes to your mind: the maximum flow is 2000 GPM, right? It doesn't mean the maximum pressure is 20 psi, right? So you have to take 2000 GPM, the maximum flow should be supplied by a pump. At the same time, you have to make sure your pump can also supply 1250 GPM at 160 psi for the standpipe system. You know, sometimes you have to make sure the maximum demands is also followed and the maximum pressure is always followed. So in this case, the hydrant system have higher demand in terms of the flow, but the standpipe system has higher pressure requirement, because you know standpipe system all the way goes from ground floor to the top one with 2.5 inch connection for class 1 standpipe system, and at that top location we need 100 psi. So imagine if your building is higher than 500 feet, right? So lots of pressure losses due to the lifting, right? 2.31 psi, and the friction loss after that again we need 100 psi. So for these scenarios, you have to make sure your pump can supply 2000 GPM. At the same time, it can supply 160 psi pressure. It can produce 160 psi pressure at 1250 GPM flow, right? So this is how you have to make some iteration, to design or select a fire pump. The next one, you have to make sure about the water supply. Either it is raw, tanks or stored, or maybe it is a municipal service mains, right? So I'm going to talk about point 2 and 3. Tank or stores must supply the demand required for your fire protection system. Let's say for a building which is protected by extra hazard group 2 sprinkler system that need 150 minutes of water supply, so that tank should supply that much quantity of water, right? Should be designed as per NFPA 22. The third one, in some countries, in the most of the Europe and those Western countries, they have municipal or public service mains, right? So those are the mains that giving supply to the fire pump system also, and at the same time they are giving supply to the utilities for various household work. So while selecting those one, you have to keep in mind the record or the hydrant flow test is not greater than 1 year. So the maximum validity for that is 1 year. Point number 1. And the point number 2 is that those testing has done at the time of the year 12 month and 24 hour a day, at the time when the demand is maximum. So for example, in the summer, during morning, Monday morning, everyone is going to school and office, and the consumption of the water for the utilities is higher. So at that case, you have to take your hydrant flow test. So make sure that if the fire happens at that moment, these two combined can goes without any problem, right? The third one, NPSHs, which is net positive suction head available and net positive suction head supply, right? So I would recommend you guys to see my video on NPSHs. There are calculation and graphs on that one before coming. If you don't know about the NPSHs available and required, the things are there. So mostly NPSHs available is a terms that is associated with the tank, and the required things are associated with the fire pump, right? So those required must come from the pump manufacturer, from the hydrant flow test, from the pump manufacturer based on the impeller diameter and all. Sorry, not the hydrant flow test. So it comes from the pump manufacturer, right? So you have to read that one and make sure that whatever required by this pump must be available at the site from the fire pump, right? So always NPSHs should be greater than, available should be always greater than required, and the gauge pressure at the suction flange should be always 0 psi. with one exception, that those exception allowed by NFPA, that if this is the suction supply tank and there is your pump at the same level, and when there is a fire for long hours and the pump is run for the pump running for the duration of the fire pump, the duration of the hazard, like, right, let's say this is a light hazard, this is an extra hazard occupancies, and that need 150 minutes supply. So pump supplied already 150 minutes and the water is now up to this level. So at that moment, if there is a fire, right, the basic purpose of the pump is that to protect the life as well as the properties. So at that moment, -3 psi is allowed as per NFPA, because better to destroy the pump rather than destroying the facilities or the life is very important. So -3 psi is the exception in some case, right? And here you can see the damage, how it happens from the NPSS, where there is a NPSS problem that causes decapitation, which damage the internal parts of the impellers. Very serious concern for the fire pumps for the long year of the service. The next one, we have to make sure that demand, the demand for the system, the pump you are going to select, the demand is not more than 150% of the pump rating. So if your pump is rated for, let's say, 1000 GPM, right, at 100 psi, the pump can also, the maximum demand from the maximum water can come from that one. It can overload work, it can work at overload at 1500 GPM, right? But NFPA recommend less than 140% of the flow. So 1400 GPM is the ideal in this case, because because of the concern, maybe after 10 years or 20 years of the life of the system, the flow and pressure, the life of the system is go down and down and down. So if you are going at 10%, giving a 10% of the allowance, for those kind of the things, good for your fire pump system. That's the recommendation, right? Okay, so here are the 3 points, right, that we need to discuss. The first point, pump rated for a specified flow. So let's say, as I said, it is 1000 GPM at 100 psi. This is the rating of the pump, and the same pump supply 150% of rated flow at 65% of rated. This is pressure. So it should supply at overload around 1500 GPM at a pressure of 65. The last point, the shut-off head shall not exceed 140% of rated head of any type of pump, let it be split, suction, or vertical turbine pump. So in that case, 140% of this case is 140 psi, right? So these are the 3 points that all of the pump manufacturer, the fire pump manufacturer, need to meet those requirements to verify the NFPA requirement on get the UL and FM testing and all those kind of the marking for their facilities. So here we have a curve, right? So this is point 1. Let's say I say this is point 1, or let's begin from the churn. Find from this point. When there is a no flow, we call it the churn or shut off. So at this point we have 140% of the head. This is the head, this is the pressure, and this is our rated capacities, right? So at rated capacities, you can see this is the 100% pressure and 100% flow. While the pumps run at overload, it cannot go below 65%, the point we discussed below, and the maximum flow can go up to 150%, right? So these are the 3 points that you have to read from the curve while selecting the fire pump. Okay, the next point is using the manufacturer curve. So mostly the pump manufacturer supply this curve, and then you have to find out what is the net pressure at your demand. Let's say your pump, your demand for the sprinkler system or your facility is 1000 GPM. Let's say it's a warehouse required more water, so 1000 GPM. What is the pressure at that one? So you have to read the curve, come to this point vertical from here, and then go horizontal to this line. So this pump is giving 1000 GPM at 100 feet, right? So it's always better to read the pump performance curve in the terms of the feet, and we know that 1 psi can lift water up to 2.31 feet. So these are the conversation that we have to carry on, right? One thing I want to emphasize here, that this is the NPSH required, as we discussed in slide number 3, that at this flow you can see, right, we must need something around 7, right, 7 feet NPSH, net positive suction head, 7 feet or multiplied by 2.31 to change the pressure, right, to avoid problem with the cavitation and all. So this pump need 7 feet of NPSH at a flow of 1000 GPM and 100 psi. The higher the flow, the higher the requirement of NPSH. So you can see here the NPSH is high and here the NPSH is low. Okay, the next one, the point number 6 is that add the suction pressure to the net pressure to the pump at the discharge pressure, right, and that is the demand flow, right. So mostly, you know, there are some pressure, if there is let's say if there are above ground tank at some height and there is a pump, we have some pressure because of those height, right, we have some pressure because of those height, that we have to keep in mind, and that we have to consider at the design flow. Let's say this is your pump curve, the curve, right, maybe not accurate, but just assume that one. This is the pump curve, this is the churn, and this is the rated one, and this is the just assume, right, don't go on data, and this is the overload condition, right. And then from the suction water supply, we start from here. The supply is coming like this one, right. Just wait a moment, erase all the links. Let's say this is your the pump curve, right, and this is your suction supply pressure, suction supply pressure curve, right. So if your pump, let's say at the flow of something around 600, at the flow of 500 GPM, right, at the 500 GPM, your pump are rated at 500 GPM and 88 psi, right. So 500 GPM and 88 psi. Now you are getting some pressure from the height of the tank, right, from the suction tank, and that pressure at that flow we have to combine, which is as 550. So we are taking at 550. So let's say 550 GPM. So at that time we have a pressure available of, the curve is not accurate. So let's say that the curve is like this one, right? Forget this. Or let us draw a new one. Okay. So this is the pump curve, and this is a suction supply curve, right, and this is a net one. So at this flow, if you are assuming these two, right, so here we have 90 from the pump, from the centrifugal pump, and then 30 psi from the suction supply. So the total equals to 120 psi. So we have to make sure that the demand flow we have to add, because we have some energy from the height of the tank, and then we have a centrifugal pump that get energy from the motor. So that we have to add combinedly to 120 psi is the pressure in that case. This is why I emphasize that, always I emphasize to my student and those comes to my facilities, you know, for the trainings, that, you know, whenever you are selecting a pump, give the complete detail to the pump manufacturer and tell them that, see, this is above ground tank and we have this much suction pressure at that one. Based on the height, kindly recommend the best one. You know, while doing that one, you will be selecting a highly efficient fire pumps. You know, the energy consumption will be lower, because of, if the pump need to give less pressure, the energy consumption is also less, right? So those we have to keep in mind based on the factors. Point number 7, if your discharge pressure is greater than demand, it's okay, otherwise select a new pump. But it says that if your system need, let's say 100 psi and you have a supply of 120 psi, 25 psi from the pump, that's okay, go with that one. If it is less than 100 psi, let's say it's 90, then you have to go to the next one. Point number 8 talks about check the maximum pressure produced by the pump and make sure that the fire protection system that is going to face those pressure is rated for that one. For example, most of the water-based fire protection system need 175 psi. Let's say it's a hydrant or sprinkler system, standpipe system, not standpipe system, water spray system, or whatever kind of the fire protection system. The maximum recommend from the NFPA is 175 psi, and that is more than enough, because based on the cost of the project, let's say steel pipe, carbon steel pipes, schedule 40, let's say grade whatever A or B, it can hold a pressure up to 175 psi and even higher, up to 200 psi to 50 psi. There is no problem with that one. But if you are going it's something like 250 or 300 psi, then you don't have to use this pipe, because the schedule is the thickness of the pipe. The higher the schedule, the weight of the cost of the pipe is going to higher. So most of the people think the fire protection system for their facilities as a last thing, because they want to reduce the cost. They will say, yeah, schedule 80 is very costly, we want schedule 40. So the client mostly they talk about those economical condition. So 175 psi for the most of the fire protection system is the ideal one. Except we have to accept exception. One is for the standpipe system, because standpipe system supply water up to height, all up to the top of the building. So if the building, let's say, if the building is something around higher than 500 feet and 1 psi can lift 2.31 feet, that imagine how much pressure you need to lift up to that height, and after the lift 2.5 inch connection need 100 psi. So that is an exception case, and if you says go up to 350 psi, because you have to design, you have to lift the water up to that point. So 350 psi is exception one, and the other one is the water-based system. It's very specialized system for the specific project, right, up to 500 psi or 34.5. So these are the system that designed especially for some project, and they test those efficiency of the water-based system for that one. So these two are the exception one. Otherwise 175 psi is the best solution for the project. The next one is the driver selection criteria, right? So now you have to select, keep in mind how you are going to drive your pump. Either it is a diesel pump from the diesel engine, from the electrical, or from the turbine, right, steam turbine and all. That depend on the installation cost, right? Let's say compare between diesel engine and electricity, right? So in some countries, if the electricity cost is very higher, the charge of electricity is very higher, of course they will go with the diesel engine, because the cost of the fuel is much more lesser than the electricity, right? The second option, you can say that one, if in some at installation site there are no electricity, so it is very unreliable that you take electricity all the way far with the transformer for this facilities. That's not reliable one, so you have to go with the diesel pump. If you want to buy a transformer for that one, then better to go with the diesel pump. But in most of the case in our world, that we are recommending only with the electrical pump, which is highly, if the source of those is highly reliable, go with the electrical one. It is highly effective, right? And the next point is that the other one, steam, as I talk about the steam driver. So that is in power plant, refinery and all, when they have extra amount of tremendous amount of the steam from those facilities, they can use that one instead of using the diesel engine or the electricity. The next point is the maintenance cost. Of course, you have to discuss about the cost of the maintenance. Yeah, diesel engine is much more costly than the electrical engine, but at the same time you have to look for the cost of the fuel and the installation cost. The last one, protection need. What you are going to protect? You are going to protect a healthcare occupancies, a clinical support, or a refinery, maybe a malls, residential complex. All those criteria factors a lot, right? So the best things, you have to consult fire prevention team, ASA. You have to contact the insurance company, those you are going to protect, those warehouse, refineries and all, because they are the one who will give you the correct figure for types of driver you have to select. Sometimes they need the redundant driver, based on their requirement, right? So you have to make sure what is the installation cost, maintenance cost, and the protection need. The last one is the code issues, right? The pump which you are going to select, if your country is using NFPA, then that must be as per NFPA 20 rating. There are some table in NFPA starting from 25 psi, 25 GPM all the way up to 5000 GPM. right? The next one, the pump must be listed by ULFM or any testing agencies equivalent to that. That's the other case that some of the companies going with the non-listed pumps, but I highly recommend to go with the listed one, because those kind of the pumps are not reliable one. The next one, in case of the split case fire pumps, in the suction size you have to follow 10 pipe diameter for the horizontal elbows, right? So if this is your pump, you cannot use any T or elbow in that one, because the code prohibit that one, because of the if you are using T's and all, there are chances of the cavitation, and those cavitations can causes the bubble formation and all. Chances of the bubble formation and all those causes the problem in the eye of the impeller. The fourth one, we have to maintain the net positive suction head, positive suction pressure, the one we discussed in the previous slide. And the last one, if we are using the electrical feed, that must be 2 hour fire rated. So these are the core issues, and there are also some other core issues, but the important one I have listed it out here, right? So that's the end of this series. I hope you got the point what I am trying to explain. Still, I will highly recommend you guys to put your thoughts, your comment, if any additional input, the steps that we need to add while selecting a fire pump, or if I miss something, right? If you have any suggestion, any comment, you can send me email to this following channel. You can send me email to my Gmail, learnfree@gmail.com, or you can contact me through the Facebook or the LinkedIn, or whichever channel is convenient for you. So that's for today, and I hope you have enjoyed these videos. If you like this video, please like, share, subscribe, and I'll see you next time. Till then, take care and bye bye.